continuing our Energy 101 series, this time talking about some efforts that NETL has in the realm of artificial intelligence, machine learning, and energy data. We're really excited to have the presenters we have today. I'm going to let either of them give their bio, and just to save some time, we'll jump right in. Again, you're here at the Energy 101 series, where we try to take some of the topics and research that NETL does and explain them in more broader, more background terms, and also try to bring in the perspective of the economic development and workforce development implications that successful research in these fields may bring to the region, but also the nation. So welcome again. Today's agenda, we're going to hear a little bit about the Regional Workforce Initiative that this NETL Energy 101 webinar series is from the Federal Coordinator, Anthony Armley. Then we're going to jump right into a discussion on machine learning and advanced AI from our SAMI director, and a little bit of energy data exchange information from Kelly Rose. And then Shengyang Shi will discuss use and reuse of data and opportunities that you guys may have around that, and how do we collaborate. The other big thing that we try to do is to present information on how to collaborate with these technical experts, but also how to collaborate with the RWFI. So with that, we will begin with our first presentation from Anthony Armley. Anthony, whenever you're ready.
All right, thanks, Matt, and thanks everyone for joining us today. As Matt said, today's webinar is under our Energy 101 series, so we'll take a technical topic at NETL, introduce it to the audience at a high level so it's easy to understand and apply. We'll also talk about why it's important, job implications in the future, and then potential skills that could be needed to support these jobs in the field. We try to focus on the Appalachian region with this initiative at our lab. This initiative started in 2017 under the Trump administration, where they were trying to promote jobs in energy and career fields. With the new administration under President Biden, they've continued that stance, if not ramping it up even more with job promotion. And we're, with the Appalachian region, we're right in the heart of their focus area, of really taking the opportunities with the fossil energy sector, folks that have, had hardships with jobs, and trying to turn that into a positive with new opportunities and modernizing their skills. So we'll talk about some stuff today that I think will really excite you related to artificial intelligence, machine learning, data analytics, et cetera, that our lab here in Pittsburgh, Morgantown, and Albany, Oregon are working on. The next slide, please. So as I mentioned, this is a platform for engagement, collaboration with key stakeholders like yourself that have joined us today. We feel it's critical for the deployment of technologies that are coming right out of our lab. One of the things we try to do with supporting technologies and trying to create jobs and advancing skills is something we've created in the last year or two. It's called the Workforce Work Plan. So a technology that's 3 to 5 years from commercialization. We will identify that technology, the skills that could be needed for a job, and we would provide that to technical and community colleges in our region. We don't limit it to the region, but that's an area of emphasis for us. So we're proud of it. We think it's going to really make a big difference in the next 3 to 5 years. And so it's part of our mission with this initiative. Next slide, please. Here's some updated metrics for you. So since inception in 2017, we've had over 800 individual, regional, and national stakeholders that have been a part of the Regional Workforce Initiative. An initiative that represents over 400 institutions and organizations. With our webinar series in the last year, we've had over 1,100 registrants be a part of our webinars. We've had a lot of great feedback. And then lastly, our Regional Workforce Initiative monthly e-note that we send out. It contains funding opportunities, the It contains education, workforce development opportunities, newsworthy items coming out of the lab, and just general information the region would be interested in. We've had a lot of folks reach out to us and show their gratitude for the opportunities that we highlight in the funding opportunity section. And they've gone after funds that they otherwise wouldn't even have known about. And millions of dollars have been awarded to the region just because of the sharing of knowledge that we try to do in that monthly e-note. Next slide, please. So here's an example of regional collaboration. NETL, Department of Energy, and the Appalachian Regional Commission last year partnered on an advanced welding workforce opportunity. DOE sent $750,000 to ARC. ARC matched with an additional $250,000. There was an award. There was a FOA put out for the $1 million. 5 awards were granted from ARC. And I think it's going to make a big difference when you talk about workforce development opportunity just in our region. The reason I bring this up is to give you an example and an idea of how we could potentially partner on something similar in the future. We're very interested in doing something further along these lines, as we feel the impact it's made has been substantial. Next slide, Matt. I would like to highlight those 5 projects very briefly. So the first one was the Robert C. Byrd Institute at Marshall University. They were awarded almost $337,000 as part of their award. They anticipate 18 students will obtain new employment after they're done with that workforce training. 35 workers and trainees will obtain new or enhance their current positions, and at least 10 businesses will be improved after the first year of implementation just by modernizing to this new advanced welding initiative. The next one is Belmont College in St. Clairsville, Ohio. They received almost $282,000 in funding. They anticipate within the project's first year, at least 50 students will obtain new jobs or enhance their current positions. After the 3 years later, upon completion, they anticipate those numbers will jump to 121 students and 30 workers and trainees acquiring or enhancing their current position. Really excited about these numbers. Next one, Calhoun College down in Decatur, Alabama. Nearly $200,000 they were awarded. The program will train 110 degree-seeking students during their project period. Southeast Community and Technical College in Cumberland, Kentucky. They were granted a little over $100,000. They anticipate 15 students will be prepared for employment with local businesses. And then lastly, the fifth award was with Westmoreland Community College in just south of Pittsburgh. They were awarded just under $80,000. They anticipate at least 68 students and 21 workers and trainees will obtain new positions or enhance their current employment. So again, when you talk about the new administration, their emphasis on jobs, we feel this really hits home because of all the numbers. Students and current workers are going to be able to enhance or gain new employment. And these are good paying jobs too. And I think it's something that in the future we want to really emphasize is the opportunities out there with this type of work. And so again, we welcome any ideas for collaboration on something similar in the future. Next slide, please. Newsworthy item I wanted to mention. Mentioned in the last webinar a few weeks back, but wanted to emphasize it here again. NETL Director Brian Anderson was recently named the Executive Director under the Biden administration's Interagency Working Group, which falls on coal and power plant communities and economic revitalization. NETL will be strongly involved in leading this effort over the course of the next year or two. There's a lot of funding, over $30 billion that's going to be put into this. And NETL will be leading the way. And the first step is just taking advantage of the current federal resources that are out there. There's going to be a lot of different trainings. There's going to be a lot of working groups that are going to be workshops. And then under the workshops, there could be some separate working groups get established to really take advantage, again, of the funding opportunities that are out there and trying to help these rural communities that really, again, jobs, workforce development, that's the name of the game right now with all this stuff. And NETL is going to be a big player in that. On the chat feature of this, I'm going to send a link real quick here for you to see if it's a link that'll take you to the report, the initial report. And if anybody wants to take a look at that, it's on the website at netl.doe.gov /IWG initial report. You can also find it on our Regional Workforce Initiative site, netl.doe.gov /RWFI. Slide, please. So the key takeaways with the Regional Workforce Initiative, again, we started this in 2017. We feel for NETL, it provides a platform to communicate and engage with our region. It's an important part of creating that foundation for predictive planning and workforce needs. You can't be reactive. We want to be proactive with that. And so we do that by hosting these Energy 101 webinars, describing technical topics at a high level for folks to understand and become interested in. We also hold other energy webinars, such as workforce-focused webinars. We team up with Catalyst Connection, Team Consortium, and many others over this past couple of years. We put out our monthly email, which tries to give the community and any stakeholders that want to be involved in that funding opportunity announcements, educational opportunities, and then general information related to NETL. We promote and catalyze energy and advanced manufacturing. We do that by partnering regionally. I mentioned the ARC advanced welding work initiative that we did. We've been highly involved with writing letters of support for the ARC's power grants. We're promoting innovation and entrepreneurship. Many other things that we do to try to participate and show our leadership regionally with workforce. And then I just want to say, we're primed for partnerships. We're open for business. We really want to work with you. If any ideas or thoughts on how we could partner up, please let us know. If you have any questions related to any of the topics today, my contact information will be at the end of my presentation here. And I can be kind of that middleman between the research staff that'll be speaking today and you guys. So please don't hesitate to reach out. Next slide, please. I'd like to finally take a quick moment here to give you a high-level overview of what all NETL does. I've had a lot of folks in the last year or two say, "What all do you guys do at NETL? What kind of research?" And so this is that one slide to give you that picture. So our core competencies: computational science and engineering. NETL has a top 50 in the country supercomputer, and being able to manage large amounts of data. In fact, we'll talk about some data analytics and opportunities with that today. Next is the materials engineering and manufacturing. In our Albany, Oregon campus, we have an advanced materials research lab that is pretty impressive. We do a lot of work with advanced alloys, and then, of course, advanced welding is something that we have great interest in. Geological environmental systems. We do a lot of work with analyzing rocks and finding fluid dynamics and things of that nature that goes through there. Energy conversion engineering. Systems engineering and analysis, being able to put a box around something to find competencies. And we have one of the best systems engineering and analysis groups, I think, in the world. There's no bias. We're not a for-profit organization. It's all about the bettering of science and advancing things, especially technology. And that's what we do. Technology thrusts. We're the premier fossil energy research lab under the Department of Energy's 17 national laboratories. So we do a lot of work in coal, carbon storage, carbon capture, sensors and controls. I mentioned advanced materials, even water management and rare earth elements, taking acid mine drainage and extracting the rare earth elements. We've demonstrated that in the last few years. Very proud of it. We think there's a big opportunity with that. Oil and gas is the other two areas that are big technology thrusts for us. Methane hydrates, offshore, we have an offshore program, natural gas infrastructure, enhanced resource production. If you have any questions about any of this, feel free to reach out. I'd be glad to give you more information and fact sheets I could share. But I just want to give you a high-level overview real quick here about some of the things that we do extensive research and technology advancement on. Slide, please. Here's my contact information. As I said, please don't hesitate to reach out to me. There's my phone number, my email, and then if you get a chance, there's NETL's website. There's a lot of valuable resources on there. I've hesitated to mention this earlier. I'll mention it now. This webinar today is being recorded. NETL's YouTube channel in the next couple of days. We'll have this on there. So if you want to share this with others who might be interested, please feel free. There's a lot of good videos on our YouTube channel and just related to the labs that we have and some of the technologies that we advance. So with that, I'll send it back to Matt, and I thank you for your time today.
So we're about to move on to our next presenter. Kelly, are you ready?
Yes, I just need the power to share it.
Making you presenter now.
Sounds good. Thanks everyone for the opportunity to talk with you, meet with you. My name is Kelly Rose. I am a geologist, geodata science researcher here at NETL out of our Albany, Oregon campus. But I am also the technical director for our science-based AI ML Institute, aka SAMI, because it's way less of a mouthful to say SAMI over that title. We're going to walk through briefly, and these slides will be available, so I'm going to move quickly to try to save some time for questions and discussion at the end. Please throw them in the Q&A box if you do have them as the talk proceeds. But these slides will be available, and hopefully they offer some resources for you to peruse afterwards as well. What is SAMI trying to do? So SAMI launched in 2020 at NETL based on the recognition that we already have a really strong foundation, as Anthony just highlighted, in science-based models, AI, ML, artificial intelligence, machine learning, development of those methods, application of those methods, in combination with data management, data analytics, and scientific computing, to address the nation's applied energy technology development needs. So you heard the swath of application spaces that Anthony spoke to that NETL performs research in broadly, but we have AI ML activities in a lot of those areas, and the opportunity to expand and grow AI ML informed research in those areas is significant. So the Institute is here to catalyze and build that opportunity into a reality, and also identify and bring in partners that can work with us here at one of DOE's premier national laboratories to accelerate those opportunities into the commercial sector and beyond. So I want to back up because we probably have a varied audience with, for different backgrounds. And I just want to walk through what is AIML and why now? Why is it having such a heyday, not just in the science and engineering arenas, but everywhere? It's having a big impact on our lives. So artificial intelligence is something that's been around for most of our lives. It's programmed intelligence. You could even argue the slide rule going way back, where bean counting devices are a form of artificial intelligence. But anybody that's ever used a programmable calculator has used a form of artificial intelligence. It's a tool. It's a capability that takes the place of our brain and allows us to do things more quickly, more efficiently, and calculate and get results. Machine learning is when you take that artificial intelligence and either through a supervised or unsupervised, those are very common terms that you'll hear people use, meaning either a human is overseeing how the machine is learning or the machine's learning on its own. If you haven't Googled and read about Google's artificial brain learns to find cat videos, this was groundbreaking when it came out a few years ago, about 8 years ago now, 8 or 9. The ability of the machine to discover things on its own, just like a child in a human context discovers things and learns without being told what it is previously, that's unsupervised machine learning. What's different today and why AIML is having such a heyday is big data and big data computing. So again, starting about a decade ago, the ability for computers to be able to ingest and handle and use and consume larger and larger and larger volumes of data really came into the forefront. The technology to do that kind of computation accelerated quickly. If you think across your life now versus where we were 10 years ago, how many people have online cloud data storage for their photo archives, or are interacting with Alexa or Siri, things of that nature. All of a sudden, big data computing can just handle and ingest so much more, and we have the ability to store it and do things with it. So what is the opportunity in the science and engineering applied energy space? Well, the opportunity here is to be able to offer those same types of insights that the commercial sector has been capitalizing on in other ways, and bring it to inform energy and energy science and engineering applications. It means that we can take what used to be seemingly disparate pieces of the puzzle, one little piece here, one little piece there, one little piece here, combine it with models and analyses, data science, AI, ML, machine learning models, and derive insights, even for the places where we don't have actual physical data measurements, and be able to make better predictions or new discoveries even. There's a lot of ways in our daily life that AI, ML has skyrocketed. Autocomplete, virtual assistant, image recognition, even self-driving cars. There's so much that we now just take for granted that's AI, ML assisted. And in the applied energy space, this is also taking off. This is an example just of papers, publications in the technical science and engineering realm that are now using different AI, ML methods and tools. And you can see that, again, this is a body of science that has been around for a while, AI, machine learning, but around 2015, it really starts to take off. And the number of publications and the breakthroughs in this arena, because of that big data computing technology breakthrough, is catalyzing breakthroughs in science and engineering as well. And that's what Sammy's trying to capitalize on for the applied energy and environmental space as well. So what is Sammy trying to take care of as far as our space goes? We've identified three major challenges. Science and engineering applications are very complex. Self-driving cars is an example from the more commercial sector of a very complex system that relies on AI, ML. But when you think about energy-related systems, we don't always have great data, or we don't have access to great data. We haven't, as a society, done a great job of curating our data, making it usable, machine readable, accessible, or the data just doesn't exist. So there's an issue or a challenge here that Sammy's helping to address. AI, ML models for science and engineering can be complex, which means that it takes innovation to develop them, but we also have to make sure that people that are consuming the results understand what those results mean and are comfortable with those results. They're validated, they're trustworthy, so that the results then can be used to derive benefit for society. And it's important, again, to make sure that we are consistent with our practices so that we are providing impactful but valid information. There's a lot of opportunity, not just in AI and ML, but in research in general for, correlation doesn't always equal causation. And so you need to make sure that what results you're getting are defensible, explainable, and trustworthy. So in the commercial sector, and I'm not going to unpack this diagram too much, but in the commercial sector, things tend to be, I don't want to say they're simple because they're not, but they're a little more repeatable. There's a lot of repetition to things, buying habits, shopping habits, search habits, the image recognition software that's in play. Your face isn't changing that much unless you have an accident or something that causes a major change. And then your smartphone might not unlock on that face recognition because suddenly you don't look like you anymore. But they've been able to develop a lot of algorithms and tools with these very repeatable and big data driven activities that are getting smarter and smarter. And we're able to leverage those into more complex engineering and science-based problems, similar to what those that Anthony introduced at the beginning. The challenge here is we don't always have perfect data. So one of the ways that we are addressing that is there's an approach in AI ML using physics-based or science-based knowledge and models along with the data to help derive those breakthroughs and AI/ML findings for these systems. So these are complex, and there are complex ones in the commercial sector as well. But that opportunity to take subject matter expertise, knowledge, and historical lessons learned, if you will, and combine it with the data, combine it with big AI/ML, is really driving breakthroughs today. And there's a lot more opportunity to do that. I'm going to skip this slide to be sensitive to time. And Anthony went through this, but we're doing this through Netl and through SAMI for a number of application spaces already, and we're growing those opportunities going forward. To grow those opportunities and to make AI/ML more user-friendly, rapid, efficient for all kinds of the applied energy and science-based applications, you still need enough data to be able to crack the nut of those problems. So one of the approaches, again, that we're really focused on that I'm going to unpack here today, because there's an opportunity with the workforce development focus of this particular audience for folks to catalyze on data that Netl and the FE Carbon Management Office through DOE has been making public for the last decade plus, to innovate new solutions using AI/ML-based modeling and ensuring that it's following good standards and is repeatable, defensible, explainable. There's a lot of documentation on how important data and that data foundation is to unlocking the potential of AI. This is one quote from the National Security Commission on Artificial Intelligence, that AI technologies will be the source of enormous power for companies and countries that harness them. But there's also this MIT technical review that just came out recently that basically highlights and spotlights the success of AI is dependent on data. Just 13% of even commercial organizations excel at delivering their data to their consumers to drive AI/ML breakthroughs in an efficient, effective way. DOE is continuing to evolve this, but Netl and FECM has been working on this for over a decade, that data infrastructure strategy for our user base for applied energy systems. What do I mean when I talk about data management? Well, if AI/ML models are data-driven, you have to have the data to be able to inform the models and do the analytics, and you need data for validation and verification that your outcomes are appropriate. If you're going to do big data, you need a lot of data. And finding that data, getting it, exploring it, understanding it. Data comes in all different formats and styles and types. It comes from different sources. Some of them are trustworthy. Some of them may be less trustworthy, but it doesn't mean the data isn't usable, but it means you need to understand data once you do find it, integrating it and labeling it. This bottom 2/3 of what we call the data pyramid is one of the biggest lifts and the most time-consuming parts of AI/ML data science related activities today. And ironically, the opportunity to use AI/ML to unlock and make this more efficient is significant and something that we've been working on here at Netl. Ultimately, you want to get to the top of the pyramid where you can use models and AI/ML methods to analyze and interrogate that data, derive insights and new breakthroughs. But it all starts with that data foundation, which is the bottom 2/3 of the pyramid. The tech industry itself is facing challenges in their domain alone. Quote from IBM a couple years ago now, but the CEO of IBM, data challenges are halting AI projects. They are still facing problems down here. We have the same problems in the research realm, but even a minimal investment in this bottom part of the pyramid can help unlock and make more efficient breakthroughs at the top of the data pyramid. So what has Netl been doing? Like I said, for the last decade, they've actually been investing in what we call the Energy Data Exchange. You can read about it through the URL here at the bottom of this slide. EDX is an online virtual data library and laboratory. It allows you to interact with data, but it also has a lot of capabilities that help you find data, transfer it, interrogate it, even publish data if you have your own data products, and preserve it for longer term access and reuse, because just like a library, which is a good source for knowledge and resources for the cross-cutting realm, digital libraries, data libraries have a lot of the same opportunities and to curate and make accessible those resources. And that is what EDX is doing. It preserves products from over 20 billion investments in research projects from the fossil energy carbon management programs. It connects users to other public resources, not just our own products, but those out on the web that are authoritative and aligned to the applied energy mission space that we operate in. And we're actually increasingly embedding our own machine learning, natural language processing technologies to make data more discoverable, help with reuse of data and that configuration part of the puzzle. So to wrap up here real quick, you can learn more about EDX on that site. It has search, sort, tools for interaction, a lot of information on spatial, even opportunities to visualize some of the data that's in the system. I encourage you to go explore and go mining in the platform. Through SAMI, we're constantly evolving EDX. It's changing with our users' input. We evolve it to meet the needs of the user base. One of the things we're working on now is connecting this data virtual library and laboratory to our on-prem high-performance computing resources, Joule and Watt, as well as to cloud commercial resources here in the near future. I've hit this point, so I'm going to skip this slide, but I encourage you to read it because there's some funny parables in there. But you must use data appropriately. You must validate it. That's the point that I've been echoing throughout this conversation. Anthony brought up the interagency working group on coal and power plant communities. The reason I threw this in here is this is an example. These are two figures from that report where my team and I used data analytics and big data analyses to help identify in a quantitative but simplified visualization those areas of FE job-centric communities where there's a lot of reliance on fossil energy related jobs from both the coal sector, but also coal and oil and natural gas. There's opportunities because of EDX and SAMI to take the data and information from that fossil energy carbon management sector that we've been curating and ingesting, the models, the tools, the data sets that are available through EDX, again, for the commercial sector and the workforce to get creative and catalyze new job opportunities. Just because the data came from that sector, there's a lot of opportunities for its reuse in other application spaces as well. So to wrap up here, for this workforce initiative conversation that we're having, I just wanted to touch briefly on how and what AI/ML skills you might want to think about if you're curious about exploring EDX and other data sources, other tools, other capabilities. There's a lot in the open source. You can learn a lot through YouTube videos, through online training. Stanford, MIT, other universities offer a lot of open source data science, AI/ML based training. That you don't have to go to that analysis side of the equation. You can also stick to just the data mining side or visualization, database and processing. These are all sectors that are in high demand, and the ability, again, to tackle the bottom 2/3 of that pyramid and help analysts and modelers and scientists and engineers be more effective in their models with AI/ML is just as important as the tip of the pyramid. Because without the bottom 2/3, you can't do the top. I liked this graphic. It's tied to AI professionals, but I would say for data science, data management, you need to be a critical thinker. Ask yourself, what is it I'm trying to achieve? What is this data doing? What do I want to do with it with AI/ML? How can we push it further? Even if it's not perfect data, is it still usable or is it inappropriate? You have to be curious. You need to be able to take breaks, pause, but not get overwhelmed, because when you're learning Python or other coding languages that come with the AI/ML data science space, it can be really frustrating. One character out of place, your code doesn't run, but you need to be able to persevere and learn and gain experience. And having at least an interest in math and science doesn't mean that you're a mathematician or a scientist or engineer, but understanding how they think just a little bit so you can communicate and connect with them to be able to do that kind of work is also equally important. So I'm going to hand off to Chong, who's going to walk through some of the, an example of applications in the AI/ML sector. But just like Anthony said, we're committed to catalyzing the future of data-driven AI/ML breakthroughs for the applied energy and environmental mission space. There's a lot of opportunity in what we've already developed for folks to capitalize on it and take it further. And you're always welcome to learn more or connect with us through the links that you see here. So thank you, everyone.
Thank you, Kelly. That was great. That was a really great presentation, a really good overview of the AI/ML, not only at NETL, but more broadly. I think a lot of people always think about the endpoint with AI and data and ML, but don't really see all the stuff that needs to occur for a solution to present itself. And so thanks for bringing that to our attention. Chung, I am moving the presenter to you, and you should see that shortly.
All right. Let's see. Okay. I hope everyone can see my screen.
We can see it. Thank you.
All right. Hey, good morning, everyone. My name is Chong Shi. I'm a senior strategic data scientist and a technical fellow at Lido supporting ATL. I'm really excited today and honored to be able to share with you the opportunity for use and reuse data. And for reuse data, this is a concept where we're applying data for an activity or for a purpose other than its original intent. And you can imagine there are many use cases. So today I'm focusing from the artificial intelligence and machine learning perspective. And thank you, Kelly, for presenting Sammy so well for this great overview. And I also want to thank Anthony and Matt for organizing this event. So I'm not going to talk too much about this slide, but here there are some leaders from the SAMI Institute. And I'm on the far right, the technical lead. For SAMI, data is a critical component because we are collecting this data and integrating domain experts, data scientists to work together to innovate AI/ML systems to solve today's energy challenges. And by AI/ML system, I want to elaborate a little bit more here. It's different than the software that we're using right now, where a software engineer or teams can come in and write thousands of lines of code or thousands and thousands of lines of code to instruct the software to behave certain ways at certain events. For AI/ML, we also have code or models but those are empty shells, like algorithms or different models. Without information, have the instructions to do or behave in a certain way that we want it to. So another critical element is data. Data meaning text, numeric data, spatial temporal data, given that it can be maps that Kelly just showed, or it can be video, images, audios, all the information that you can think of. And by feeding those data into the model or machine, we let the machine to pick up the patterns, learning the relationship between the parameters so that it can itself predict what behaviors to have during certain events. So this is AI/ML system. And let me give you an example. This is a project that we did to predict shale gas well production. And for shale gas well, it's different than the conventional well where operators drill a vertical well down into a reservoir on a very high level or simplified version as a pot of oil, and then we extract and produce from there. For shale gas, they are trapped within the shale rock formation spread across a wide area. So the operator drill, instead of a vertical well, they drill a horizontal well to maximize the reach, which is a very clever design. And in order to open that fracture, they fracture the shell and have the ways to control the opening so that the natural gas can flow freely into the natural gas well. And our target was using the first 12-month production in million cubic feet of gas equivalent. And the reason we picked this first 12 total production is that oftentimes we see the decline of a production maybe around a year or so that if we have a higher number of first 12-month production, then we can have a good indicator this is a good performing well. And in order to do that, we have need several types of data. And this is just some of the data that we use just for illustrative purpose. And thermal maturity, thickness, gamma ray, those are indicators of how the organic content in the subsurface. But we also need the completion data because how you complete the data could dramatically impact the production as well. And once we have the data, we feed those data into different models. Again, these are just illustration purposes from kernel ridge, neural network lasso, or support vector machine regressors. And once we have that, we can let the models to pick up the patterns within those data and trying to predict, or from these combinations of parameters, we will generate a certain type of first 12-month production. So this was how we did for the first project. And now let's talk about how we can reuse the data to do more. So with the same data set or a slight modification of the data set, but when we change the model configurations or architecture, and again, it's an illustrative purposes. We have more models, but with the different types of models, instead of predicting the first 12-month production, I'm using an example here, like 256 MMCF GE. It's a number, but we can now do a monthly production. So as you can see, the blue line here indicates the actual production from a well, and the red line here is the prediction from a machine learning model using a neural network. And you can see the machine pick up the pattern really good, even though it didn't know what the actual monthly production. So with that, the model can capture the trend and predict the monthly production. And if we can predict the monthly production, then we can calculate the estimate ultimate recovery, EUR, which is the total production over the well's lifespan. And if we can do that, we can, of course, predict the well lives. We can know how many years of operations we can get out of that well or that investment. And if we can do that for one well, we can do that for many wells. So we can talk about like regional resource investment, understanding how much resources underground, and we can prioritize our drilling activities and maybe even use the models to help us optimize our completion design so that we can maximize the production. So these are just some examples that we can, through the same data sets, we can answer different types of questions. So as you can see, with proper data and model, we can answer more questions and acquire insights than we originally expected. And this leads to this point. Data is the energy for AI. This slide is modified based on a recent talk by Andrew Ng in 2021. he was describing the overall workflow and level of effort for a machine learning project. And 80% of the time, talking about that 80-20 rule, 80% of the efforts are going into preparation, collecting high quality data. And I think Kelly also mentioned in the pyramid. So a lot of the effort went in, and just like if you're a chef, you want to prepare the best meal, you'll probably spend hours going to the market, picking up the best ingredients, and you probably ended up just spending 5 minutes stir fry a dish that is corresponding to the 20% of the action that's training or tuning the model. But Andrew and his team, he went on and do an informal survey that looking at the recent publication in AI/ML. And what he found was 99% or the majority of the research are focusing on the new algorithms, new models, how to train and tune a model, but only 1% of the data research is about how to systematically collect and curate all those data. And this is an area that Sammy is really focusing and really care about, because we want to have a systematic way and consistent way to help us reuse model. Another example is recently there are a fair principle being proposed that we see that's very valuable, which is findable, accessible, interoperable, and reusable. And I listed the sub principles here related to reusable. But the key is here. Metadata is very important, and by metadata is the information to describe the data itself. So oftentimes, because the limitation of field names, we have to use code or use abbreviations. Using an extreme case, I might use a P for pressure. But if I don't have a better description, well-defined metadata, other people might think this P may be a production, right? And even if they know it's a pressure, they don't know what this pressure is for water or for gas things, and what is the unit for this pressure. So having a metadata is really important, and how we curate that, collect it is very important. But the problem with you reusing data is not just about metadata. Here, I'm listing the level of effort throughout the project's lifecycle, from conception, planning, execution to closure. And you can see there are different levels of efforts, but they're not just a distinct period that we're doing execution. There's overlapping portion. But when you look at the data deliverables, oftentimes we only starting to capture or package data in the execution phase, where we're having the draft version 1, and then version 2, and then we have the final data set, and then final data set version 1 and 2 and 3, until the final day that we have the final data set delivery as our grand finale. But through this workflow, you'll see if we're not careful, a lot of the original concept or planning, why we pick certain things or certain R&D directions, might be lost. And later on, we might not know why we have this type of data. Right? Those are critical information. And we proposed is to have a living data workflow that the green bar is showing here. We're trying to capture all the information that we are using throughout the project lifecycle from start to finish. And Kelly mentioned about the EDX++, which is the smart data platform that we're working on. One that Kelly already mentioned, the connecting off-premise, on-premise computing resources. What I'm talking about here is the environment, where we're building extensions and applications within the software packages that we use daily throughout the project lifecycle. For example, like we might have ArcGIS for mapping and different tools for chemical engineering, material, and manufacturing, so that we can create different environments that from geospatial to data leveraging EDX API. So through this applications or in extensions, we're reaching out and having those tools embedded every step of the way when we are making progress in our projects. And the question is, what is your data need? We really want to know and learn and work with you to help solving those challenges, because this is what we're striving for. We want to create the problems to solve today's energy challenge. And I'm ending up by showing this slide that Kelly just showed. We talked mostly in the smart data platform EDX++ today, how to read the problem and how the approach to solve the data reuse problem. But sometimes if we don't have the data, we have the science-based AI ML modeling by leveraging our existing physics or scientific knowledge to generate syntactic data, or use this physics laws to help guide training the machine learning algorithms. And also we're working on how we can consistently having the best practices standards to do machine learning, so that at the end we can have consistent results or workflow that we can compare apple to apple. So with that, I really, again, want to reiterate, if you have any problems you're facing, challenge you're facing, please share that with us, share with Anthony, and we would like to work with you. And again, my name is Chong-Shi, and thank you for your patience to listen to my talk today. Thank you.
Thank you. Thank you, both presenters. So we have a couple of questions. So let me just make myself the presenter again. Okay, it's not letting me do that. So we have a couple of questions from the chats. For Kelly, should classes in statistics or self-paced online courses in statistics be considered before machine learning self-training?
Yeah, absolutely. And I put in the chat, you can get entire degrees. One of the things that's interesting about artificial intelligence, machine learning, and even data science that I didn't emphasize, and I meant to in the talk, is it's multidisciplinary. You can't be an expert in everything, but I'm a geologist by training. Over the years, through self-training, online courses, just osmosis, listening to people who are coming from different subject matter areas, you start to pick up their language, and understand their perspective. So the only caveat I put on the statistics, if you are into statistics and that's going to be your hook, your niche into AI, ML, data science, perfect. Go to town, take lots of advanced courses. But if you're just wanting to be conversant and have a good foundation, I suggest searching for statistics classes and spatial statistics. If you're working with anything that has a spatial element to it, it is its own body discipline. Look for those courses that also put those topics into a data science framework, because they'll be a little more cross-cutting, maybe more consumable to start. They'll get you going. And just be mindful, you don't have to be a PhD statistician, but you do need to have enough of a knowledge base of statistics and statistic language and tools and methods to definitely pursue a career in the AI ML data science space.
I think one of the things that both talks kind of highlight, in a practical matter and yours in the background matter, is that there's so many different entryways in the discovery pipeline around data analytics, AI, ML. Again, I think people really just kind of have the endpoint always in mind, like that there's going to be self-driving cars and all these other things, but they don't understand that there's maybe perhaps still a huge discovery phase that needs to occur even when you have the data. And I guess you hinted upon that, where the data could take you only so far, and then you still have to do, experimentation and hypothesis testing, because correlation does not mean causation. And I guess what you're saying is you will get a lot of correlative data from these big data sets, but then they still have to be worked out, and those have to be worked out by people, I guess, I'm assuming. So yeah, just speak a little bit about like all the potential different entryways there are, even on that end, on the discovery side. And you're a good example of that.
Absolutely. I mean, data science, AI, and machine learning, definitely, like I said, there are people that go into that discipline and make a career from the get-go in that arena. But a lot of people come at it from, an analyst, a database technician, computing science, and even subject area, just, knowledge, expertise avenues. And so don't feel, it can feel overwhelming. And that was in one of the slides I had. It said you have to be resilient, my word, not theirs, but you have to be able to persevere. And, it's one little bite at a time. It is a journey to embark on this path, but there are little stops on the way that you can become an expert in database architecture and design. You can become an expert in acquiring and transforming data. And through those paths, you'll start to gain expertise and experience in analytics, AI, ML, because those tools are part of the toolkit. And you'll learn the vocabulary. You'll become more fluent, and your ability to then work with subject matter experts, or maybe you're coming from an SME perspective, but you're layering in this skill set, this expertise base that just enriches your ability to do more and more over time. But view it as a journey. There's going to be milestones along that journey that you could even make into a career. But you'll keep evolving, and this is a technology-centric area, and I mean, all you have to do is look at the latest smartphone that comes out, or the latest laptop, etc. Technology is constantly evolving and pushing the boundaries, and the opportunity to do that in this applied energy, environmental, data-driven space is huge. But just be resilient, be creative, be curious. And give yourself a little bit of grace as well, because you will get frustrated.
This question is for Chung. On your presentation, I guess they were looking at one of the XY axes data. Did you try to estimate the slope, the decrease in production? I guess this is from the modeling of production efficiency in wells. Did you try to estimate the slope, decrease in production? What were the best predictors for this well production attribute?
Yeah, we did predict that and estimate that, and I think the key would be, what we want to understand through our project was, why machine learning pick up certain patterns, and how to understand, what the connections from data to the final behaviors, because just like our institute's name, we want to have the science base. We don't just want to use the data for or machine learning model as a black box. So that's something that we did, and of course, welcome more detailed discussion. I think like we're on time, and I want to take more time. But yeah, I welcome more discussion on that. Thank you.
We'll just take one or two more minutes from everybody's time. I just really wanted to give an opportunity to you guys to speak on, and Kelly, maybe this would be perfect for you. What does it mean for the U.S. to be the leader in AI and machine learning? Like, what type of potential economic opportunity and impact does that mean? Because it seems like there's a lot of energy towards that, and yeah, so why are we all doing this? Like, what's going on? So,
I would say, AI, ML, data science, big data computing. These are all, in some ways, there are people that make their career out of innovating new solutions in these areas, but they're also tools, and they are tools that are here to stay, and they are transforming the landscape of what we can do, that I showed with some of the statistics and charts in the presentation earlier. So the opportunity to catalyze breakthroughs, to solve problems we previously couldn't handle because they were just too big for the infrastructure that we have, the algorithms that we had, the opportunity to be transformational, even in the small day-to-day stuff, is huge. And there's so much untapped potential there. And that's where, from a workforce initiative perspective, we brought up the IWG report and the opportunity to see those fossil energy centric historical communities pivot in new directions. Well, there's this treasure trove of data and this new application capability technology space with AI ML. So it just takes human creativity and ingenuity to catalyze new commercial sectors and do new things with it. So I think the potential for the US to be a leader in this space, continue to be a leader in this space, is significant. But the potential for even the individual to make an impact with these tools and with these capabilities is basically only limited by the creativity of each team, each group.
Well, Kelly and Chung, thank you so much for giving us a very broad 360 view about what you're doing at NETL, why it's important, and what the ramifications are, potentially workforce and economic development wise. I think we could have another one of these just looking at the workforce element of this, like the tools and training. A lot of our stakeholders are in the technical workforce space, and I think there's huge implications for both y'all's research in that. So we'd love to have you back on just on a workforce kind of discussion, as we didn't have too much time to talk about it this afternoon. And thank you again. Anthony, do you have any closing words?
I thought Kelly and Chung did an outstanding job of taking what I consider a complex topic area, making it so folks like myself could better understand what it is exactly, why it's important, and then, especially here at the end, talking about skills and economic impact that this has. I'll tell you what, and I was talking to Bill and Don here on the chat related to some programs Pitt has. This stuff right here is big time as we move forward. These skills are not only in demand in our country, but across the world. And, NETL, like I said earlier, we're open for business. If you have interest in talking to us further about any of this stuff, collaborative ideas, please don't hesitate to reach out to me, and I'll get you connected to the right folks. So I really appreciate everyone dialing in today. And like I said earlier, this was recorded. We'll have it up on our YouTube channel here in a few days. So thanks again, everyone. Have a great day.
Thank you, everybody.
Thank you all.
Bye.
Thank you. Bye.